Hello and welcome back to another Unreal Engine 5 video. I'm Ben Blau and today's topic is going to be sockets. Now, sockets have to do with what are known as skeletons, and skeletons have to do with what are known as skeletal meshes. You have been working with skeletal meshes whether you realize it or not. For example, if I go into play, the body of Quinn is a skeletal mesh, right? And that skeletal mesh is unlike a static mesh because it is rigged with a system of, well, not actual real life bones, but representations of bones of a skeleton. If we wanted to examine the bone structure underlying that skeletal mesh, we could do that. Here in the content browser, if you double click on the characters directory, double click, and then we go into this folder, mannequins, and then one more into meshes. Here we can find the character meshes, all of them. If you read the bottom of the thumbnail, I think you can see they all say skeletal mesh, except for this asset right here, which is just called skeleton. As it turns out, Manny and Quinn both share the same exact skeleton. So let's look at that. I'll double click that and we're going to open up this view. So what we see here on the left is the hierarchy of virtual bones that make up the skeleton underlying this character. And you can select them from the list and it will show you roughly where they are. Where is the pelvis? Where is spino 1, spino 2, 3, 4, 5, the left clavicle, let's say the left pinky, anything, okay? It even gets very, very granular here with things like index finger, metacarpal right, okay? So we can animate things like fingers if we need to. So this is a very good example of a skeleton for a skeletal mesh, such as a character mesh. Now, as it turns out, in Unreal Engine 5, you can also look at the skeleton from the previous generation, which was the Unreal Engine 4 skeleton. So let's back up one level to mannequins, and then back to characters. And this time we're going to navigate into the mannequin UE4 directory. And again, under meshes, we can see the model, which is this, it's this asset, the skeletal mesh. We will talk about physics assets some other time, but this is the skeleton for the UE4 mannequin. And you can see that we've got a similar looking hierarchy of bones. The main thing that allows animations to work is the fact that any bone on a skeletal mesh has a transform. That means that it has a location, it has a scale, and it has a rotation. So for example, if I were to take the upper arm left, I can modify its rotation on any axis. I could have done this in the other skeleton if I wanted to. And any other transform property. So for example, the upper arm, if I wanted to, I don't know why I would do this, but if I wanted to scale it, you can do some pretty crazy things. Okay, but in any case, I suppose that might be cool if you were making some sort of bizarre character. But in this case, I just wanted you to understand that every bone has its own set of transform properties. And that's a big part of what makes animation possible for skeletal meshes. Okay, so I think that you get that point. Now, in regard to the bones of a skeletal mesh, one feature provided by Unreal Engine and other game engines is the ability to add what are known as sockets. And sockets are a way of attaching other actors to specific bones of a skeleton, which of course will in turn be visible, that is, if you choose for them to be visible, at that location on the skeletal mesh when you're playing the game in the world. So in this example, let's do something rather simple. I'm going to scroll down to Quinn's hand_R. By the way, that's all lowercase, and there's an underscore. That's worth remembering. Most of the bones work that way, by the way. They are lowercase. So I'm going to add a socket to this right hand for Quinn to hold on to something. To do that, I'll simply right-click on the bone and choose this option, Add Socket. So I will click on that, and now I have something called hand_r socket. If I double-click that, I can rename it. Maybe I want Quinn to be holding on to some sort of ball, for example. I could name this whatever makes sense to me, ball_socket. And notice that it is indented underneath the right hand. That means that its parent is the right hand. So once I position that ball correctly relative to the right hand's transform, it's going to ultimately follow the transform of the hand. And when you're working with sockets, you can also add what's called a preview asset. If you just want to get a general idea of how to situate that object so that it will end up being in the right place. So I'll right click and I'm going to add a preview asset, and I'm just going to search for, let's say, material sphere. Okay, I want to use the one in starter content. And as you can see, that's gigantic. So I'll go to the details panel and I'll set the relative scale. Unfortunately, I don't think there's a way to padlock this, but let's try 0.125 on the X, 0.125 on the Y, and 0.125 on the Z. Okay, that looks like a ball that Quinn could hold on to. We don't have to worry about adding a material or anything at this point. But right now, that ball is welded basically to that socket. And we can create an offset from the socket so that it looks like it is in the correct location in Quinn's hand. Now, when you do this, I recommend reducing your camera speed, and I'm doing that in my case by right-clicking my mouse button and zooming my center scroll wheel in or out. If you happen to be looking at the upper right corner of this viewport, you'll notice that my camera size is changing as I do this. Not my camera size, I beg your pardon, my camera speed. Okay, because I don't want to be flinging around here while I'm trying to position this accurately. So we're going to go really, really slow. So for this, I do like to turn off snapping in most cases. And let's play with first the transform of it. Obviously, it's too high up. So let's get it into the hand so that it looks like it's being held onto. I like to check this from many angles because I want to make sure that this preview asset, and we can offset this. If you accidentally click off and you're trying to reselect the ball, clicking on it is not going to work. And clicking on the preview material sphere is also not going to work. It's really the socket itself and its transform that we're adjusting when we're applying these offsets. So again, I like to look at this from multiple angles because I don't want either mesh clipping into the other. Okay? So maybe here, it's a little bit hard to tell. And take your time doing this. When it looks right from multiple angles and nothing is clipping, chances are that you've done it right. Okay, so now I've got this socket called ball_socket, all lowercase. Now I can save the skeleton this way, so I'm going to move my mouse up to the upper left corner and click on the Save button to save the asset. If I were to go back to my regular map and get back to my content browser in its root directory, remember that in the third-person template, the BP_third-person character is located in this folder, third person. We'll double-click that, open up Blueprints, and here we'll find that third-person character. So now, if I double-click this, I can do most of my work from the actual viewport. All right, so we know that we want the ball to appear in Quinn's hand, and it's not going to do that by default because it is not a component inside of our components panel. I do want this ball mesh when I add it. And the ball, by the way, is a static mesh. So when I add that component, I am going to need for it to be a child of the skeletal mesh. So I would recommend selecting that first. So I've selected mesh, character mesh, and in this case, we're using Quinn. So at this point, with that highlighted, I'm going to add a static mesh. And that should come up right away if it doesn't just search for static mesh. So I've got my static mesh, and I can rename this ball mesh if I want to. That makes sense to me. But just calling it that in the components panel doesn't actually specify which mesh you want to use. So once again, I'm going to search for material, sphere. I want the one in starter content, so I'm checking the path right now. So that's the one that I want. And you'll notice that that is not really in the right place at the moment, but we have yet to specify what socket it belongs to. So I remember the name. I can search for it basically just by clicking on the magnifier. And if I type ball, I'll find it quickly. Ball_socket. Okay? And how about that? Right into the hand, exactly where we put it before. You still have the option of scaling this and applying materials to it and whatnot. So why don't we just choose a material at random? How about red? Find something red so I don't have to make a brand new material. Is that red? It's transparent red. I don't want to have to make a brand new material just for this. We'll say tutorial. Okay, that's fine. If I compile and save, you'll notice that when I spawn into the game, I am now holding onto that ball, and its transform follows the transform of the socket, which in turn follows the transform of the hand. So this is a way that we can attach objects to different parts of the skeleton. So how is this going to be useful for us? Well, in games, sometimes we have to attach things to characters' hands, like magical orbs or weapons or any number of things. And we're going to apply this in the context of Project Eridel for something like a magical sword or a magical staff or something along those lines. I want Eridel to have it worn around her wrist at first, sort of like holstered, and have an animation that the character performs to unholster the weapon and get ready for battle. So yeah, that's the basic idea of sockets, and we are now going to apply that to a real project. In our case, we're going to apply it to Project Eridel. So I will see you there in just a moment.